my name is Mastro, and today I'm going to talk to you about a fun little project that I did. A little while ago, I decided to write a point-and-click adventure game for MS-DOS, which is a 16-bit operating system, and for the processor, which is an Intel 8088. Yeah, so I just want to, first off, give everybody a warning that you should not use any part of this talk as general C++ advice. First of all, I'm not using C++ 11, and writing for a 40-year-old CPU is a very specific use case. But yeah, let's talk about that use case. So when we're writing anything, we want to make sure that we know what our goals are. So first of all, we want good performance, and in this case, we want speed because it's a video game. We do not want to run out of memory, which is really important because we only have 640 kilobytes to work with. And we want well-defined behavior, which is especially important given there's no memory protection at all on a Intel 8086. So how do we do those things? The first thing you got to think about is you want to keep your code small. My binary is only 48K, and the size of the binary matters, not only because we only have 640K, and 48K is a significant amount, but there's actually a performance benefit, which I won't get into because of the time, for keeping your code under 64K. Another thing you want to do is you want to avoid accessing memory as much as you can, because that is by far the slowest thing you can do on the 8086. And you want to use your instruction set to its maximum ability, because it's a very complicated instruction set, which is actually designed to get the most out of such a slow CPU. And one way you can do that is by just reading the output of your compiler, checking what the decompiled thing looks like so that you actually know what your compiler is doing. And a little suggestion is this: keep simple solutions because they tend to be the best. So let's get into a few examples. To make sure you know what you're doing, let's take a look at this. So this is a piece of code for plotting a pixel on the screen. It's a little contrived because I don't want to have to explain some stuff, but anyway. An int on the 8086 in most C++ compilers is 16 bits. And so does anybody see what is wrong with this? If you guess that it overflows, you're correct, because basically, when you multiply those things, it ends up exceeding a 16-bit integer. And the one thing you might want to do to keep track of all these things and see exactly what you're doing is to always use size types for everything so that you can see what happens. And that also helps when you're optimizing things for performance, because you can actually see where the conversions are happening. The other thing you want to do is you want to design the code around the machine. So in my game, the music is provided by MIDI, and there are a couple different sound devices you can use to play back that MIDI. So one thing I do is when I'm handling MIDI messages, I use a table of functions to store how to handle that message, or this is like a note on or a note off, make a sound kind of thing, for the different devices. So it turns out that on the 8086, there's a really great instruction that will actually it'll take a function pointer plus an offset, dereference that pointer, and then call that function all in one instruction, which is pretty cool. And as a result, this code ends up being really short, and it ends up being a pretty efficient way to play back MIDI on the 8086. So the other thing you might want to do is you want to break the type system when it helps. So for example, the problem with this is we just have two lists of pointers, but the problem is that you're instantiating the template twice because they're actually two different types. So that's actually going to take a ton of memory. I know this sucks, but using a void pointer here actually saves like 5K of memory, and I just wrap that up in some fancy, well, really stupid things to get over that. So there are some fancy CPU instructions, and you want to take advantage of those when you can. And one of them is rep move SB, which is a crazy instruction that copies bytes from one location to another location, increments both pointers, and then does that again as many times as you want without even branching. So it's super cool. But how can we use it? Well, one of the ways we can do it is just use memcopy, because that does that internally in most 16-bit compilers. And so, for example, one place I use that is when I'm updating my color palette, because that needs to be done really quickly before the vertical retrace finishes. And so one of the things, what do you do once you've done all you can and it's still not good enough? Well, unfortunately, C++ isn't always the answer. And I had to write a lot of these graphics routines in pure assembly language. And I even had to create my own language for writing adventure game sort of logic in order to compress the space that it used. And so, yeah. In conclusion, like, doing this kind of code is really not that difficult as long as you pay attention and kind of keep it simple, and even just do stupid things when you need to. So I'd like to thank the Open Wacom version 2 project. They are the compiler that I used, and they were very helpful to me. And if you want to find me online, you can find me here, or you can find me after the talk.